Good morning, good afternoon, everyone. This is Miss Mate, and we will continue our discussion about techniques of finding the limit of a function. Today, we will do a change of variable. Given the function f of x equals 2x over x plus 27 to the power of 1 over 3 minus 3, we want to find the limit as x approaches 0 of f of x. Now, as usual, whenever we start evaluating a limit, we want to see if at that point x equals 0, the function has a discontinuity. So what we're going to do, we will substitute the value x equals 0 into the equation, and let's see what happens. Do we end up with an indeterminate form or not? It's going to be 0. 2 times 0 is 0. 0 plus 27 is 27. To the power of 1 over 3, that's a 3. Minus 3, that's a 0 over 0. It is indeed an indeterminate form. It is an indeterminate form. Now, let's move this out of our way. We will take a look right now at the graph of this function. The graph of this function was generating using technology, and I recommend you do that on your own. What do I notice? I notice that as x is approaching 0, both from left and from right, the function seems to have a limit. I don't know how much that limit is, but it's somewhere in that area. It seems that both from left and from right, the function is approaching a certain value. Okay, so how do we eliminate the discontinuity? Algebraic. We're gonna do a change of variable. We're gonna rename this part of my formula x plus 27 to the power of 1 over 3. I'm going to use a new letter. So I'm going to say that x plus 27 to the power of 1 over 3. Let's call this t, for example. Okay, so my f of x becomes, using this new name, my f of x becomes at the bottom, t minus 3 is not a problem. But at the top, I have 2 times x. I cannot use x anymore. I have to use my new variable, which is t. So I need to isolate x. How do I isolate x? Looking at this expression over here, I'm gonna raise both sides of this expression to the power of 3. Power of 3. Let's see what happens. Left side becomes x plus 27, and the right side becomes t to the power of 3. As a result, x will be t to the power of 3 minus 27. So the top of this function is t cubed minus 27. Okay, so I can evaluate limit, but the limit is as x approaches 0. I don't have x anymore. I have to see what happens with t as x is approaching 0. As x is approaching 0 here, x is approaching 0 right here. 0 plus 27 is 27. So t cubed approaches 27, which means t must approach 3. So my new limit, instead of limit as x approaches 0 of f of x, can be written now as limit as t approaches 3 of 2 times t cubed minus 27 over t minus 3. So it's going to be limit as t approaches 3 of. Now, for that part, I'm going to use a formula that you know very well, or I hope you know very well. a cubed minus b cubed, it's a difference of cubes, is a minus b times a squared plus ab plus b squared. Remember? So it's gonna be, that part over there becomes 2 times t minus 3 times t squared plus 3t plus 3 squared plus 9 over t minus 3. Look how lucky we are. T minus 3 t minus 3 is gone, so I don't need this. So my limit becomes limit as t approaches 3 of 2 times t squared plus 3t plus 9. So it's gonna be limit, no more limit, I'm gonna evaluate my limit. So it's gonna be 2 times 3 squared plus 3 times 3 plus 9. So it's gonna be 2 times 9 plus 9 plus 9, 2 times 27, 54. Result that makes sense in the context of our graphs. Yes, both from left and right, my function will approach 54. Done.